In this video, I'm going to show you how to do AQA A-Level Maths from June 2018, Paper 1, Question 15. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire, England for in-person tuitions. A curve has the equation y equals x cubed minus 48x. The point A on the curve has x coordinate minus 4. The point B on the curve has x coordinate minus 4 plus h. Show that the gradient of the line AB is h squared minus 12h. Okay, so the way that we would work out the gradient of a line would be rise over run, or y2 minus y1 divided by x2 minus x1. So we need to work out the coordinates of point A and point B. Okay, so point A has x coordinate minus 4, so we'll call that x1, and y coordinate, which will be y1, will be, we're going to use minus 4 and put it in the equation for y, so minus 4 cubed minus 48 times minus 4, which gives us minus 64 plus 192, or 128. Right, now we're going to work out for point B. Point B is going to be, the x coordinate is going to be x2, which will be minus 4 plus h, and its y coordinate will be y2, and we're going to substitute minus 4 plus h into the equation for y, so it'll be minus 4 plus h cubed minus 48 times minus 4 plus h. Now, to expand this cube, we could use binomial expansion, or we could multiply it out completely. So if you were to think about the cube, which I'll write here, minus 4 plus h cubed using binomial expansion would be 3c 0. We'll do it from decreasing powers of h, so it would be h cubed times minus 4 to the 0, which of course is just 1. 3c0 is also 1, so we can get rid of that. So here this would give us h cubed plus 3c1 times h squared times minus 4 to the 1. 3c1 is 3, and then minus 4 times h squared, so it will be minus 12h squared, plus 3c2, h to the power 1 minus 4 squared, which is 3 times 16, or 48, and then h to the power 1. Can't quite fit it on here. 3c3, h to the power 0 minus 4 cubed, which is minus 64. We also need to multiply minus 48 by minus 4, which gives us plus 192, and minus 48 by h, which is minus 48h. So the gradient here, is y2 minus y1 over x2 minus x1. Well, the top of this is going to be h cubed minus 12h squared plus 48h minus 64 plus 192 minus 48h, and then minus 128, and then the bottom will be the y coordinates, the x coordinates, which is minus 4 plus h minus 4. Okay, this now simplifies. The top of this will simplify. Let's have a look. So we've got minus 64 minus 128, which is minus 192. That cancels out against the plus 192. Plus 48h minus 48h. Those also cancel out. So the top becomes h cubed minus 12h squared. The bottom is minus 4. That becomes a plus 4, all divided by h, which simplifies to our final answer, h squared minus 12h. Okay, so that's part A of the question. Part B, explain how the result of part A can be used to show that A is a stationary point in the curve. So a stationary point is a point where the gradient is 0. So what we know is that if we were to move the points A and B close together, the curve, which is currently a chord to the curve, would gradually approach a tangent. So as h goes towards 0, AB goes towards a tangent. So which implies that the gradient of AB goes towards the gradient of the curve at A. And so we can't say that h is equal to 0, but the limit as h goes to 0 of h squared minus 12h is equal to the gradient at A, and the limit of as h goes to 0 of h squared minus 12h is equal to 0, so stationary point. And that's the end of question 15.